Okay, page 181 in our Nulake book. Let's just remind ourselves about SOHCAHTOA. You can see I've written the 3 triangles at the top of my page, so I'd like you to do that too. And just to remind ourselves that sine of the angle equals the length of the opposite side divided by the length of the hypotenuse. Cosine of the angle equals the length of the adjacent side divided by the length of the hypotenuse. And tan of the angle is the length of the opposite side divided by the length of the adjacent. I'm using theta to stand for an unknown angle, or to stand for the angle. Often we use x for sides and theta for an angle. Right, beginning with the first problem, we're asked to find the length of the side with the p beside it. I can see it's a right angled triangle, so I can use trigonometry. You might want to think about using Pythagoras' theorem, but unfortunately we don't have the third side, so we can't use Pythagoras' theorem. Labelling the sides, I've got the hypotenuse, which is always the longest side, and it's always opposite the right angle, so that's how we know that's where the hypotenuse is. The side down the bottom is the opposite, which leaves me with adjacent for the side beside the angle. Now, the third side here is nothing written along it. It's not going to be any use to us in this problem, so don't write the O beside it. By writing just the H and the A, we can now select the correct triangle to use, and I can see that cosine would be the correct trig ratio to use to help us solve this problem. So looking at this triangle, drawing it bigger for ourselves, I can see that cos of 41 degrees, the angle, cos of the angle, the adjacent side has length p at this stage, and the hypotenuse is 6.45 metres. Right, there's a time sign in between here. It's really important we use one line of correct working. P equals, we'll write the number first, the 6.45, and then I want to multiply that by cos of 41. Cos of 41 is a decimal stored inside our calculator. You need to make sure your calculator is in degrees, and if you're not sure you can ask about that. And you should get a value of 4.87 metres to 2 dp, giving the units and the stating the rounding. Make sure this side, of course, is smaller than the hypotenuse, because the hypotenuse should always be the longest side. Right, question 100. Let's start by labelling the side. So I've got the hypotenuse again, which is always opposite the right angle and the longest side in my right angle triangle. This side is clearly opposite the angle. The third side is not part of the problem, so we'll ignore that, which clearly shows me that I should be using the sine ratio for this one. So drawing our big triangle, sine and the angle in this case is 42.4. Opposite side is q, and the hypotenuse is 24.8, and there's a multiplication sign in between. So once again, one line of working. Q equals, now we'll write the number first, the constant, the length of the hypotenuse, and then I want the sine of 42.4. So over on my calculator, gives me a value of 16.7 metres to 1 dp. And just check that it is in fact shorter than the hypotenuse, which is the longest one. Now just skipping down a couple of questions to number 103, let's have a look at what happens with this one. So I've got the hypotenuse, I've got the adjacent side, so I know I'm using the ka triangle, and I'll just put it here since we can't see it up above. Right. The third side's not part of the problem, so we won't label that and confuse ourselves. Now the cosine of the angle is 46.1. The adjacent side is 64.2, and the hypotenuse is labelled t. Right, I can see that this problem is going to involve division this time on the calculator. So having a look at t, one line of working, t equals, we'll make sure we write it the same way as it appears in the triangle, with the 64.2 divided by, that's what that line's doing, cos of 46.1. And you can pause and have a go at that on the calculator and just check that you get 92.6. We're in millimetres, and that's to 1 dp. It is the hypotenuse, so it should be the longest side. So that explains when we multiply and when we divide.